To be looking at how to find the circumference of a circle and the length of an arc. These are their objectives. By the end of this video you should be able to solve some real life problems involving arcs and distance around the outside of a circle. Later this year we will do investigations regarding the nature of what pi is and the relationship of the pi to its circumference, but we're not going to do that in this lesson. Okay. We should all know this, that the diameter is twice the radius. Okay, first of all, we're going to find the circumference of a circle with a radius of 6 centimeters. The formula we use is 2 pi r, which is the same as saying pi times the diameter, because the 2 times pi times r is the same as saying 2 times r times pi, which is diameter times pi. Usually in maths you use 3.14 just to 2 decimal places in pi unless the question states otherwise. So you can see here all you do on your calculator is type in your 2 times pi or times 3.14 times 6. You will end up with 12 times pi, and your answer should be, depending on what you used for pi, the answer should be 37.7. Notice there's no unit there, so the circumference answer at the bottom has the unit, which is 37.7 centimeters in this case. When you are finding the circumference, when you're finding the radius, so this is the other way around. It's the same principle, you're just basically using some basic algebra here. So you're given the circumference of 31 meters, not centimeters, and you are asked to find the radius and round your answers to 2 decimal places. Again, we've used the formulas. That's the first thing you write in mathematics, is the formula. Then you substitute into the formula, which is what we've got here in the second line. To get the r by itself, because that's what we're trying to find, the radius, we divide this side by 2 pi, and we've got 31 divided by 2 pi, which is 2 times 3.14, to equal r, and then we've just simply used our calculator to find that answer, and that's given us the radius of 4.93. Okay, next one we're talking about is the length of arcs. This is actually quite simple, it's not hard. You just need to think of the common sense of arcs. The arc length is a portion of the circumference of the circle. So first of all we need to find the angle of the sector, with the arc that we're in question, that we're trying to find. So you can see down the bottom here, we've got four basic examples of the 4 most fairly common examples to help you understand. The general rule is the angle divided by the angle of the sector divided by 360 times 2 pi r. Now we know from previous section that 2 pi r is the entire circumference. Once you know the entire circumference, you only need to find out the fraction of the circumference that's in question, in this case the arc that is contained on the outside of this sector. So to find the percentage or the fraction of that entire circumference, you just find the fraction that is concerned. To find that fraction is the angle over 360 that finds that angle. So in the first example, it's 180 divided by 360, which is a half, times 2 pi r, and so on and so on. You just type those numbers, so it's 0.5 times 2 times pi times the radius, whatever that would be, and that would give you an answer to find the length of that arc. Okay, the length of the semicircle is half the circumference, and the length of 90 degrees arc is 1/4 of the circumference. That's pretty obvious. So let's look at an example here to try and help you understand this. So we've got an angle of 100 degrees. So we are concerned with 100 over 360, or 10 over 36 of the circumference. So 10 over 36 of the circumference. We've worked out the circumference by going 2 times pi times 7 to give us an answer of 43.96. And then we need to find just the length of that arc, and we multiply that by the fraction that's concerned with the arc to give us a total length of the arc of 12.21 centimeters. That is correct full working out and setting out. You start with the formula, use this theta sign. Theta in this case is just referring to the angle in question. Theta is the most common Greek symbol that we use when referring to angles, over 360 degrees, which is the total degrees of a circle, times 2 pi r, which is the circumference of that circle. So theta over 360 degrees times 2 pi r, then we substitute into the formula. Then we've got our working out, and then we have a solution. Usually to find, you can either write answer equals, or length of, in this case we've written length of arc equals 12.21 centimeters. Notice it's not centimeters squared because we're not talking about square units, we are talking about distance. And that's it.